All right, let's go on page 103 when we're done. And we're going to talk about polar coordinates. Those circular graphs I told you you will see on the mock and you won't have any idea what they are. That's what we're going to talk about today. Okay. All right, so let's just talk about traveling a little bit. Let's say I wanted to go from here to Dallas. I could drive to Dallas. I could get my little handy dandy map on my phone and it would tell me go down here, turn left, go down here, turn right. And basically it plots it out for me on a rectangular coordinate grid, right? Yes, there's some curves and stuff, but it's still basically like we think about X and Y, turn right, turn left. I could also fly from here to Dallas because I can't go directly to Dallas by driving, right? But I could fly. And that's not really a straight line. And it's not because the airplane goes up and the airplane comes down. Okay, you can just pretend like the airplane stays, even if the airplane was started up in the sky, the Earth still has a curve to it, right? And not as dramatic as from here to Dallas, but think about flying from here to London, right? Then clearly I'm going to have to go in some sort of curve, right? And so those are two different ways to travel. And like I said, if I'm heading to Dallas, flying might be better than driving if I need to be there quickly, but driving might be better because it's cheap. Like there's ways to make choices, yes? So there's ways to make choices on these things as well. And that's kind of what the first two paragraphs say, but I don't want to just read them to you. And then it goes on to say plotting points in space is not much different than the transportation examples. Okay, so up until this point, the only system you have learned has been the rectangular coordinate system, right? That's what you've been using to plot points forever. It uses an X and Y axis or independent and dependent, and you have a point with an ordered pair of X, Y, or whatever the variables are for that. Okay. It can also be called the Cartesian plane or the Cartesian coordinate system. Again, they have different names, but it's similar to a road grid. All right. Now, what we're going to talk about today is an alternate way to describe a point in space, and that's with the polar coordinate system. With the polar, we do not use X and Y to define points. That's not how we're getting there. It's much more like flying. And to define a point, we need to state the angle of the point and the signed distance. Okay, let's talk about what's signed, and it's S-I-G and not S-I-N-E. Signed distance. Because we talked about the difference between distance and displacement. Distance is always positive. Displacement could be positive or negative. But we also have what's called signed distance, which means that allows my distance to be negative, but it's just kind of an understanding in the question, right? So if you know it's a signed distance, it's kind of like the displacement, kind of the same thing. All right, so let's look at how that works here. Even though this still looks like an X and Y axis, right? We'll look at the little circle things in just a minute, but we'll just kind of have that there to make sense of things. So in polar coordinates, this point is defined by r theta. So instead of xy, it is r theta. The absolute value of r is the radius, because the radius is still always positive. However, it is possible to have a negative r value. And then theta, that just represents the angle in standard position, like we know how we've been rotating from 0. Same thing. So if I want to get from here to here in the rectangular coordinate system, I'd have to go to the right and then I go up, and that's how I land there, right? But for polar, instead, I would go out the length of the radius and then rotate around whatever the angle is and land right there. Okay, does that make sense? That's the difference there. And one really cool result, or one reason why maybe polar would be better in some situations than rectangular, is that the same point can be represented many different ways. And it's actually not just many, it's an infinite amount of ways. All right. Everybody good so far? All right. Let's flip this over. Let's see how we plot points in the polar coordinate system, but let's talk about this polar grid first. We know that if we had the rectangular coordinate system, we've got X and Y, and a lot of times a ton of little boxes, so we have all these parallel vertical lines and parallel horizontal lines. Well, instead of having that, we have what kind of looks like, I mean, they're not parallel circles because that doesn't exist, but you can kind of think of them that way. They're concentric circles because they all have the same center. And it still looks like we have an X and Y axis in there. You won't see that X and Y axis in every polar grid you ever see. It is on most of what we've seen for this. I'll still talk about it as an X and Y axis because it's what makes sense to us, but know that it really kind of doesn't exist here. The polar axis is actually just this part right here. It's just what we would consider the positive x-axis. It's just that ray. That's it. And then the origin, we could still call the origin, but it is also called the pole. Okay, everybody good with all that? Then let's look at these lines that go through my circles. And we can see that we have these three angles labeled for us. And they're the big three that we already know and love. But notice that there's a line on either side of those that doesn't have anything on it. Most of what we have had with the unit circle, those extra ones weren't even there. But and things, so it looked like things weren't spaced evenly. It's kind of like if I was going to have a bunch of horizontal lines in a rectangular grid, I wouldn't just skip one and have a big space. So when it's actually a graph, you kind of need everything to be spaced evenly. And so most of the time they are split up this way. You don't have to know what those values are. I'm going to tell you what they're on. We're going to talk about them, but you do need to know like where pi 6 actually starts when you have all of those. So if I have 1, 2, 3, 4, 5, there's 5 radii drawn in between 0 and pi halves, then, and to think in degrees, because I know that makes more sense to you, this would be, they're each 15. So 15, 30, 45, 60, 75, 90. We just don't worry about the 15 and 75. And the 15, since this is pi 6, would actually be pi 12ths. Okay, not something that we're going to have to figure out, but something that we should be able to reason through and just know where your angles are when it's drawn this way. Okay, does that make sense to you? We good on all that? All right, so let's plot some points. We're going to start with 2 pi thirds. So I'm going to start at the pole. I'm going to go over to my radius of 2. Then I'm going to rotate around to pi thirds, and that's where my point goes. And it's that easy. Okay, that makes sense? So let's do that again. I've got 1 3 pi halves. So I'm going to go to 1, rotate around, end up right here at 3 pi halves. That's B. Then I have 4 pi thirds. What quadrant is 4 pi thirds in? Third. And are my pi thirds angle closer to my y-axis or x-axis? Think about, picture a unit circle. Or pi thirds, is it closer to my y-axis or x-axis? Y-axis, right? So if I'm going to go to the third, so I start at 3, right? Because that's my radius. If I'm going to go to the third quadrant, I need the angle that's closer to my so-called y-axis, but remember I don't use that one, so it's this right here, and that's C. Also, notice that 4 pi thirds and pi thirds are on the same diameter, and that should make sense because they're reflections of each other, right? Everybody good so far? All right. Then we have 2 negative pi 6. Well, we know what to do with negative angles. It's not any different than what we've been doing. I go to 2, I rotate a negative pi 6, bless you, end up right there, bless you, there's point D. Questions about how we get those? Okay, it really is that simple. There's no trick. I know sometimes when things are easier, like, okay, what's the trick? We're just not done, but like plotting points is pretty simple. Everybody good? All right, so let's look at the next one. Says plot and label the following polar. Okay, so I want you to go ahead and put 2 pi fourths where you think it is. And then check to make sure that we agree. Right, went out to 2, rotated to pi fourths. We experts now? Yep. All right, so then you go ahead and plot B. 2 negative 7 pi fourths. What quadrant does negative 7 pi fourths land in? The first. Good. So I'm going to be in the first quadrant. I'm going to go to 2. I'm going to rotate around to negative 7 pi fourths, and look where I land. The exact same spot. All right. 2 9 pi fourths. What quadrant does 9 pi-4ths live in? First. Very good. We'll go all the way around. Oh, look where I end up. Exact same place. So there's actually, and I know we haven't done D yet, but there's actually an infinite amount of ways to get there, right? It's like running around a track. Now, if I was going to put this exact same location on the rectangular coordinate grid, I'd have to start here, move to the right, go up, and that's literally the only way to get there, okay? As far as an XY is concerned, that's it. But with polar, you have lots of different options. All right, so now here's our first one that has a negative R. There are multiple ways to approach this, and sometimes I like to show you more than one way because, you know, whatever works for you. But just from my experience in teaching this, I'm only going to show you one way because it's the way that pretty much everybody gets. The other ways I will tell you include some adding and subtracting of pi's and stuff and some other stuff that instead of having it all mixed up in your brain, you need one way. So I'm going to give you what I believe is the best way for you to do it at this level anyway. So I've got -2 5 pi-4ths. When I have the negative R, here's what we're going to do. We're going to start by just putting our pencil down, not plotting the point, but putting our pencil down where +2 5 pi-4ths is, because we know how to do that. Right? So go ahead and find where you think 2 5 pi-4ths is and put your pencil down. And I think it's right here. I'm just going to put a tiny, you don't even have to put a dot, but just so that I can move out the way and you can see it. Okay, y'all agree that that's where it is? Okay, so when you have a negative radius, you put your pencil down where you believe the positive radius would go. Then you stay on this diameter, this line. You go through the pole to the other side and make your point. And that gives me D. Okay, so let me say that one more time. We pretend like it's positive, put our pencil down, but since it's negative, I have to basically reflect across the pole. So I've got to go through the pole to the other side and make my point. Okay? What questions do you have? We good on that? We think we're good on that so far? We'll plot some other negatives, don't worry. All right. Well, if we're good, grab your other sheet of paper. This is also going on page 103 when we're done. So this says, example 2 that we just did illustrates how a single point in polar coordinates can be expressed in many different ways. In fact, there are infinitely many ways. This one, we're going to kind of do the opposite. We are going to come up with other ways to get to a specific point instead of having ways to, you know, where they give us the ordered pairs. So we're going to plot this point, 3 5 pi-6. So go ahead and plot that point, 3 5 pi-6. I believe that that's there. Do you agree with that? Are you done with yours? Okay. All right. Then it says we're going to write the polar coordinates for the point in 2 different ways, but we're going to be a little extra. We're actually going to do 3. There are an infinite amount of ways, but there's what I consider 3 simple ways to do that. And so if you are asked for just 1 or 2, if you know 3, then you can decide which one makes the most sense to you is kind of what I think about. So we're going to come up with 3 other points, 3 other ways to get right there to that same point. This one has a positive radius. So I'm going to have 1 more with a positive radius and 2 with a negative radius. Okay. And when I say the easiest, it's kind of like the most direct without having to do more than one rotation going in either direction. And every time you do that for any point, you'll have 2 with a positive radius, 2 with a negative radius. Okay, so to get here, we went to 3 and we rotated around counterclockwise. I can also start here and I can rotate clockwise to get to this point. So I can have a +3, but a negative angle. And if I'm going to start here and rotate around to here, that's going to be a negative what? 7 pi-6. Very good. Everybody okay with that? Okay, now the next 2 have a negative radius, which means that when I land, right, when I land wherever I'm, coming from and I'm pretending like it's positive, I have to land on the direct other side here. Wasn't even staying on the same. There we go. So I'm going to put a little star here because my point's there. Like this is where I want to land when I pretend like it's positive, and then I'll pass through the pole. Okay? So I'm here. If I go this way, I would go from here all the way to my fourth quadrant. It's still a pi sixth angle. What's my fourth quadrant pi sixth angle? 11 pi 6. So if I was given this ordered pair, I would go to 3, 11 pi 6 right here, but the radius is negative, so I'm going to pass through the pole, and I'll still end up in the exact same spot. Okay, you see how that works? Ask me questions if you're not sure where things are coming from. All right, so then one other option is to start here and go negatively to get to this point. So that would be negative what? Pi 6. So this would get me to negative pi 6, and then I have a negative 3, and I end up over there. Okay, so all 4 of those polar coordinates will get me to the exact same point without having to do more than one rotation. And it's fine, like, it's fine to do more than one rotation and come up with ordered pairs that way, but this would be a multiple choice question. So really, you need to be able to find a couple and then know how to know if they're the same or not, is really what that comes down to. Okay. What questions you got? Anything? Awesome. All right, so let's connect the two together now. We've got rectangular coordinates, good old stuff we've been doing forever. I know that if this is my point xy, which we'll say it's actually square root of 3 over 2, 1/2. That means I'm going to go to the right, square root of 3 over 2, and I go up 1/2. Everybody agree with that? That's how we get there. It's like our old school rectangular way. But for polar coordinates, well, let's think about this. If I have an ordered pair that is the x value square root of 3 over 2, y value is 1/2, and I'm on the unit circle, what's that angle that goes with this one? Pi 6, right? Square root of 3 over 2, 1/2. So instead, if this is 1, I could go to the right 1 and rotate around pi 6, and I'm going to end up at the exact same point. And I think if I had a polar grid, I could plot that point way more accurately than I could plot this one in the rectangular coordinate system, because I'd have to estimate that decimal, then kind of guess at where I'm plotting it, right? So when you have to decide, do you use rectangular or do you use polar, it kind of depends on the information that you're using, what your purpose is, all that kind of stuff. The good news is you're not going to have to decide which one is best. You're just at this level going to do what they tell you to do, all right? But there are definite pros and cons to both in a lot of situations. So then if we connect it all together, now back in the day, y'all might be too young to have ever had an overhead projector in your classroom, but those little clear transparencies, if I had this transparency and this transparency, I could stack them on top of each other, because this point lives in the exact same place this point does. It's not like they're different points. It's still the same location. It's still Dallas. It's still going from here to Dallas. That's all it is. So that means here, this is going to be square root of 3 over 2. This is 1/2. This is 1, and this is pi 6. And that's exactly the whole thing we did the very first day we did the unit circle. Right? What questions do you have? Anything? All right, so then we need to be able to convert between the two. And what we do to convert, we've really kind of already done, but we weren't talking polar at that point. We know using trig that cosine theta is x over r, sine of theta is y over r. Old business. If I take these two and I solve for x and y, I get x equals r cosine theta, y equals r sine theta, okay? Which is your mg cosine theta, mg sine theta in physics. It's also your x and y value for a circle that's not a unit circle, which was on your last test that so many of you seem to have never seen before. So this might seem like new information, which makes me sad, but it's not new information. But then here's a little tip, which is important. Whenever you're converting, always sketch out the point. All right, so let me show you what we mean by that, and let's convert. We've got this right here, and this is r theta. And then even though it's a polar coordinate system that's a circle, I'm not going to start by drawing some wonky circle. I'm still going to draw what looks like an x and y axis, because then I can think about a circle being there kind of like we do with the unit circle, right? Just to give us something to go with. And So 2 pi would mean I go out to 2, rotate around to pi. It would be somewhere like right there. Okay. Then we're going to find it, and I'll tell you why that's important to us. So I'm going to find x. X is equal to the radius, which is 2, times the cosine of theta, which is pi. So I have 2 times, what's the cosine of pi? -1. Very good. So that gives me -2. Right? That's my x value. Then my y value is r sine theta. So r is 2 times sine of theta, which is pi. What is the sine of pi? 0. So this gives me 0. So that means my ordered pair is -2, 0. So when I have this here, and I look at my little sketch that I had, well, -2, 0, if I do that in the coordinate system, that makes sense for that point, right? So when we're sketching them for these here, it's really kind of for reasonableness, like, do I think I did this right and mess anything up? For the next one, it's way more important for us to get our actual answer, okay? Any questions at this point? All right, so let's sketch this one. 4 5 pi thirds. 5 pi thirds is in which quadrant? 4th. And it's closer to the y-axis, so it'll be somewhere kind of right there. We're not trying to get anything perfect. It's okay. It's even okay if we just know 4th quadrant, but that could kind of help us too. All right, so x equals r, which is 4, times the cosine of 5 pi thirds. So that's 4 times 1/2. Very good. And so that gives me 2. Then y is 4 sine of 5 pi thirds. What is the sine of 5 pi thirds? Square root of 3 over 2. But it's what? Negative. Very good. Negative square root of 3 over 2, because we're in the 4th quadrant there. So then that's going to give me -2 square roots of 3. Everybody good so far? I am a little worried about some of your trig values, like enough where I felt like I had to say this in every class. And it may not even be people in every class, but I'm still going to say it every class. I'm worried about some of you not knowing your trig values, especially from that last quiz. It was kind of a hot mess. So my ordered pair is 2, -2 square roots of 3. So on this one, if I think about the fact that this means I go to the right and then down, but I'm going to go farther down than I did to the right, then this being kind of closer to the y-axis makes sense. Like, I feel like my answer is reasonable. Okay, any questions? All right. So I want you to put where you think that point would be. Since it has a negative radius, I want you to try it, and then I'll talk you through it. Just kind of put a point where you think about where it would be. Okay, so I'm going to pretend like it's a +3. 7 pi 6 would be about right there. Then I'd go through the pole, so I'd end up kind of right there. Okay, does that make sense? And again, at the very least, just to know you're in the 1st quadrant is helpful here. All righty, so I'm going to get x equals -3 times the cosine of 7 pi 6. Now here's the important thing to remember here. Yes, I just put a point in the 1st quadrant, but this is still a 3rd quadrant angle. And in the 3rd quadrant, cosine is what? Negative. So, and then the cosine of 7 pi 6 is negative what? Square root of 3 over 2. Very good. So then that's going to give me a +3 square root of 3 over 2. Sorry, that looks terrible, but that's 3 square root of 3 over 2. Because negative times negative is positive. So y is equal to -3 sine of 7 pi 6. So that's -3. And then what is the sine of 7 pi 6? -1/2, right? So then that gives me a +3/2. So my ordered pair then is 3 square root of 3 over 2, 3/2. And that's positive, which is a 1st quadrant point, and I'd go to the right farther than I would go up. So I feel like that looks good. So that's how that negative radius works. Okay, it helps you flip the sign of the SIGN of the trig value. Okay, what questions do we have? Anything? All right, so then we got to convert going the other way. From rectangular to polar. Well, this uses stuff we already understand as well, Pythagorean theorem. If I have x and y and I need r, that's literally just x squared plus y squared equals r squared. And then if I have x and y, I know that tangent is y over x, and then I can find theta. And again, it says always sketch, and that's going to be way more important here. Because remember, there's an infinite amount of ways to write an ordered pair for a polar coordinate. And I don't want to have an infinite amount to choose from when I'm trying to decide what to write. Okay. Excuse me. So let's go ahead, and this is rectangular, so I'm going to plot the point. Go, all right, negative 2, 2. It's somewhere kind of right about there. Then I'm going to find r, so I'm going to do Pythagorean theorem. Negative 2 squared plus 2 squared equals r squared. So that gives me 4 plus 4 equals r squared. So r squared equals 8. R equals, okay, before we do this, remember we can have a negative r value, right? That is possible. And so I could choose here to use either a positive or a negative because they did not give me any guidelines. But to make this simpler, we're going to just be consistent in what we do. We're going to always use a positive r when we're finding this unless we're told otherwise, because then that kind of narrows down what we have, which means I'm just going to go ahead and make that decision because it'll make it easier to figure everything out, that I'm going to have the square root of 8, and that is 2 square roots of 2. Okay. So there's my radius. Then I need my angle. I know that tangent theta is equal to y over x, so that's 2 over a negative 2, and that gives me a negative 1. Now, I'm not using my rules that we had when we did, just straight up inverses and we had to use the fourth quadrant, that type of thing. But tangent is, is negative in 2 different quadrants. But which quadrant do I want this to be in? Second, right? So what reference angle, what first quadrant angle gives me a tangent value of 1? Pi fourths. So then I need my second quadrant pi fourths angle. What's that? 3 pi fourths. So that means that my ordered pair is 2 square root of 2, 3 pi fourths. Now, because this would be multiple choice, that might not be one of my multiple choice answers. But the safest thing to do is to find that point and then know how to find other ways to get there if that's one of your answer choices, okay? Rather than getting lost in trying to find a negative angle or do whatever else, okay? Because you can confuse yourself on that. What questions do we have? Okay, we're going to stop here today. All right, I'm going to go ahead and finish this just so I can get this uploaded. So on B, we are going to plot our little point. So 1 negative square root of 3 would be somewhere right about there. Doesn't have to be perfect. Just, get it so that it is at least in the fourth quadrant. We do Pythagorean theorem. 1 squared plus negative square root of 3 squared equals r squared. So 1 plus 3 equals r squared. R squared equals 4. So r equals 2. Because remember, we're just going to go with the positive version here. And then tangent theta is y over x. So that's negative square root of 3 over 1. And I want a third quadrant angle. The first quadrant angle that gives me a tangent value of the square root of 3 is pi thirds. So I need my third quadrant pi thirds angle, which is 5 pi thirds. So that means that my answer for this one is 2 5 pi thirds. And if I think about it on a polar coordinate system, I'd go out to a radius of 2, rotate around to 5 pi thirds. That seems like a decent answer. Alrighty, on C, I've got 0, negative 5. So my point, pretend like it's on there. I can't. There we go. So 0 squared plus negative 5 squared equals r squared. So 25 equals r squared. So r equals 5. All right, tangent theta is equal to negative 5 over 0. That is undefined. Tangent is undefined here and here, so clearly that's the one I'm using. So theta is 3 pi halves. So my ordered pair is 5 3 pi halves. So let's think about it on polar. I'd go out to a radius of 5, rotate around to 3 pi halves. That's where I end up. Sounds good. Now, on this one, I really didn't have to do all that work, because rectangularly, if I know I'm at 0, negative 5, really for any of the quadrantals, then I know that this length is 5, which would make a radius of 5, and I'd have to rotate around to 3 pi halves. Same thing works for this one here, because we had the polar point of 2 pi. We rotated around there. So I know that that length is 2. The length is 2. Rectangularly, to plot that point, I'd be at negative 2, 0. So we did the work on them because I don't want you overthinking it and thinking you can guess at things. But for the quadrantals, really, you should be able to come up with either one of them. Okay, and there are your points for polar.